Well, good morning, boys and girls. We're looking at the 2020 tables, equations, and graphs paper. And we're looking at question 2, which I'll work through today. So the first question is to sketch the graph of y equals x squared plus 2x minus 8. Now we're used to seeing, or at least when we're sketching the graphs, it's nice to have the equations in either this format, which sort of shifts the vertex about and will move the whole parabola a to the left and the right and b up and down. In other words, here's your horizontal translation, here's your vertical translation. Or we can use this format where we find the x-intercepts and then continue to work from there. Now, because this equation factorizes reasonably easily, we're going to use this option and not that one. Okay, we could use the first one, but that's more work. So we want to look and do it in the most efficient way possible. So let's go ahead and factorize this. We get x and x, and we get 4 and 2. One of those needs to be negative, one positive. So let's make this one positive, that one negative, because that works. And I've got now that same equation, but in this format right here. Let's just double check that we've got that right. And it's always good when you're working through a problem that you just double check your work, because one little mistake will mean the whole thing won't work. So x times x is x squared, negative 2 times 4 is negative 8. And then we do this part here, 4x, negative 2x, and that adds up to 2x. So we've got it right. So that's good. We can now go ahead and sketch that. By the way, if I set that equal to 0, then I get x, the intercepts then are x is equal to 2 and negative 4. So that's where we need to put those points, 2 and negative 4. And we'll just zoom out a little bit so that we see what we've got. Next thing to do is to work out the y-intercept, and remember the y-intercept occurs when x is equal to 0. So let's work out the y-intercept. Y-intercept is when x is 0. So 0 minus 2, 0 plus 4, and that's equal to negative 2 times 4, and that's equal to negative 8. So we go down here and it intersects there. So that gives me the y-intercept. So I've got x-intercepts, y-intercepts, and I'm looking now for where is the vertex, okay? Where is the vertex? Well, the vertex must occur halfway between negative 4 and 2. So halfway between negative 4 and 2 is here at x equals negative 1. You can count squares, there's 6 squares across. We can count 3 from either end. Or we can go negative 4 plus 2 is negative 2, which we divide by 2 to find halfway. And that's there. So somewhere along this line, probably down here, somewhere along this line is where that vertex is. And it's got to be below negative 8, because this is on its way down, right? Looks as if it might be negative 9, but let's just confirm that. Right. How do we do that? Well, this is negative 1. So to find the vertex, I need to substitute negative 1 into the equation. All right, I've got x is negative 1. I know that. So if I substitute negative 1 in, and we'll just use the factorized equation that we've got negative 1 minus 3, negative 1 plus 4, and that gives me negative 3 times 3, and it's 9. Look at that. That's what we thought it was, and there it is there. So let's choose, I think green's a nice color for a parabola. So we'll go ahead and best we can sketch that through there, and I'd probably want to do that again. I've missed that, but look, that's okay. All right, you can see there that it's supposed to go through negative 4 and 2, passes through the vertex, and negative 8. It's a bit hard on an iPad with a pencil. So that's that one done. Let's look at the next question. There we are. Tui and her volleyball team practice hitting the ball over the net, shown in the diagram. There's your context. Okay, so volleyball. Height of the net is 2.4 meters above the ground. So here's our net there. So we can see that 2.4, and it looks as if that red line is some kind of parabolic arch, which it is. And so there it is there. We see 2 hits the ball flies according to that red line over the net at 2.4, fine. And the x-axis is horizontal ground. So, and we've got h, which is normally the y-axis. That h is there for our y-axis if we want, or we can use h. And the first question says, how much higher than the top of the net will the ball be as it passes over it? So what we're after actually is, what is that length there? What's that length there? Well, to work that out, I know this is 2.4, so what I really want is this height. In other words, what's that height there? What's the length of that green line? What's the height at that point? And then I can subtract 2.4 from it. Well, the net is at x is equal to 0. There you are, x is equal to 0. Let's just tidy that up a little bit. I've got a bit of rubbish in there. I think we know what we're doing. So I need to substitute 0 into this equation. Now let's go and do it, and then that'll work out what height is, and then I can subtract 2.4 from that. So h, therefore, I didn't want green. Blue is proper color for calculating equations. So h is equal to negative 0.2, and then we've got 0, so that becomes 2, right? 0 plus 0, and 0 minus 8 is negative 8. So I get negative 0.2 times negative 16. So let's go and work that out. So, and we get 3.2 meters. There we are. So the height of from the ground is 3.2. How much higher is it then? Well, we take 3.2 minus 2.4. We've got how much higher? 3.2 minus 2.4. And that's 0.8. Squeeze it in there, and there's your answer, 0.8 meters. Fantastic. Here we go. Tui is concerned that the opposition players will block her shots at the net, i.e. jump up and stop a shot from coming over the net as shown in the picture. How could altering the equation of the path of the ball have an effect on whether or not her shot is being blocked? Provide 2 suggestions that are based on graphical reasons. Okay, well, if you look at this over here, so what I could do is I could change this negative 0.2. If I change that number and make it maybe 0.3, then the effect of that is that it's going to steepen that curve and do that kind of thing. Okay, and that would work. So that's one suggestion. We would say h is equal to negative 0.3, and the rest of it's the same, x plus 2 and x minus 8. Okay, and that would give it higher over the net. And you could say something like that as well, so that actually changes the shape of the parabola to give a steeper parabola. Okay, so changes shape of parabola makes it steeper. It certainly makes it steeper at the bit we're interested in. Now, the other option is if she stood back. So we're keeping the shape exactly the same, but if Tui took a step back, and let's look at that, and no, not red, we've got red already. Go back to green, which is nice. If she takes a step back and does the same thing, badly drawn, but if you can imagine that shape exactly the same, but she just took a step back, then it would also pass higher over the net. So that stepping back then means we shift everything, say 1 step to the left, and therefore we still at 0.2. We keep that the same. So stepping back would mean that becomes h plus 3, and this would become h minus 7. Okay, in other words, we're adding adding 1 to it, which has the effect of moving it back 1 step. And that would give that. Okay, so, and you could say 2e takes 1 step back, or 1 unit back takes 1 step back. And that's enough for that one. Tane is practicing his volleyball skills by throwing ball over the net. Okay, some more context. I've given some measurements. He is 3.2 meters from the net, and hits a, and there's that dimension there that we're told. So there we go. We've got that. That's basically the position at which Tane hits the ball. Maximum height. That would be important. We've got the same net again, and we're told the ball lands here. All right, so there's some information for us, but that's those two things here and here are going to be quite important. Find the equation. All right, find the equation. Well, I think in this instance, if we're using H, we need to use this kind of format. So I'm going to use A, and that's x minus b squared plus c. So we're shifting the vertex of that around. So we're going to use this kind of equation here because our vertex is right there. That's it there. It's a maximum height. First thing we notice is that this graph is upside down. Okay, so it's an upside down parabola. We can make that -8 and indicate that. Now the vertex we already know is here and here. So we've got a 1.8 meter shift to the right, and we've got a 4.8 meter lift. So B is going to be 1.8. So x minus 1.8, because that is our horizontal translation, and we've lifted this thing by 4.8, which is our vertical translation. All right, good. Now, what we have to do is we have to work out, well, what is A? Because we are not sure what shape this parabola has, but this point here is going to help us because that is on the parabola. So if that's on the parabola, we can substitute that into the equation and then work backward to find out what A is equal to. So we can substitute those in. So H is 2.3, okay, which is sort of the y coordinate, or in this case, the H coordinate, and X is -3.2. So we're going to substitute that in. So -3.2 minus 1.8 squared, and we've got plus 4.8. So let's work this out a little bit. Equal sign disappeared somewhere. So 2.3 is equal to -a. That's 5 squared, isn't it? So that becomes 25a plus 4.8. So we're going to subtract 4.8 from that whole thing. So 2.3 minus 4.8 is -2.5. Good. So -2.5 is -a over 25. And let's divide everything by -25. And we find that that's equal to 1/10. So A is 1/10. So now I've got enough to write that equation. So H is equal to negative, right? That's still there. -1/10 x minus 1.8 squared plus 4.8. And that's a tricky question. That would be that. In fact, I'm absolutely sure that is the excellence question. I haven't looked, but that'll be it. There's a bit of work involved in that. And I think that's it, isn't it? And we come to, oh no, we've got more. There's more. Oh, look at this. How exciting. All right, it's got Ruru joins Tane, standing at the opposite side of the net. Tane sends the ball over the net towards Ruru. The equation of the path traveled by this volleyball, anyway, we're given that. Ruru dives to reach the ball before it's the ground, but misses the ball. Use equations of graphs, find out how far away from the net the ball will first hit the ground. Okay, and you may choose to use the graph provided opposite. I'm going to do this algebraically, I think. Okay, so when is it first hit the ground? So we've got a parabola there, and there's the equation. So now right back over here, remember the horizontal ground is the x-axis. And the horizontal ground is that x-axis at 0. Right? Or if you like, yeah, when y is equal to 0. So then really we're looking at when is the height equal to 0? Okay, when's the height equal to 0? In other words, if the ball, if this is hitting it here, then the ball hits there at when the height is 0. Okay. And it might bounce and all the rest of it, but it talks about when it first hits the ground, So we're going to set this equation equal to 0 and then go ahead and solve it. So new equation, negative 0.25 x minus 2.1 squared plus 3.9. Okay, see that? Height, when's the height equal to 0? Right, let's shift that 3.9 over. So we subtract 3.9 from both sides, negative 3.9, negative 0.25 x minus 2.1, being careful to copy everything across correctly. And then I think I'll divide by negative 0.25. Yeah, so let's do that. So negative 3.9, and we're dividing by that by 0.25, and I get 15.6. So, oops, 15.6 is equal to x minus 2.1 squared. Now I'm going to take the square root of that. And if I do that, remember it's plus and minus. So it becomes plus and minus 15.6 is equal to x minus 2.1. Then we add 2.1, and I'll just turn this around. If I add 2.1 to both sides, I'm going to stick that out the front. Okay, so it becomes 2.1 because I've added it, plus or minus the square root of 15.6. All right, using the calculator. So we've got two solutions there. So it becomes 2.1 plus, we'll do that one first, plus the square root of, oh, dang, I've using my phone. I've left my calculator at school. That's not good. So that's all right. There we'll do 15 point, it works in a slightly different way. So it's not as good. 15.6, take the square root of that. Oh, wrong thing. You can see there, I'm struggling here a bit. We'll try again. 15.6 square root using my funny calculator. Got that, 3.9 whatever. And then add the 2.1. I just needed to do it in a different way to what I'm used to. So here we get an answer, which is 8.4196 something rather. And there's another one as well. So take that square root again. So 15.6 at 15.6, regretting leaving my calculator behind. And we're going to subtract it this time. Right. Still mucking things up. We'll get there. Trying to use my phone. 15.6. Clear again. I forgot the 15.6. You've probably done it by now with all this mucking around. Square root. Okay. Times negative 1. Subtracted it. Right. Do this. Sorry about this. 3.94. Look, the answer is, all right. It becomes out finally, I've got there, negative 1.84. So we've got two answers, 8.49, etc., etc. So effectively, it's, look, this is 8.15 meters and negative 1.85 meters. Well, go back and look at the situation and see, well, if I drew the parabola of this, all right, then we've got an upside down thing. There's 8, there's negative, and there's your parabola. Okay, so we need to think about it because the ball was going to hit there. So this answer is not sensible, which is that one there. It's sort of, it's the shape of the parabola, but it doesn't apply to our situation because it sort of goes backwards beyond to the left or behind Ruru. So that doesn't make sense. The answer is 8.15 meters, but you need to understand why this one is not true. We are done. Better just double check that there isn't something else there. But no, question 3, we've completed question 2. A long question, actually. And now,